morning. I'm sure you're all excited after yesterday's sessions talking about the Meta Quest 3. Ready to dive into some more details? I said, are you ready to dive into some more details? Great. My name is A.R. Schleicher, and I'm a developer relations engineer here at Meta. I'm proud to say I'm an original Kickstarter backer, and I've been to every single Connect. At that first Connect, I never imagined that I'd be the one up on stage presenting the details of the latest headset. So what do? Basically, I help developers solve whatever problems or challenges they might be facing with a focus on the latest hardware. This year, it's the Meta Quest 3. I'm excited today to walk you through a more detailed overview of the Meta Quest 3 headset and Touch Plus controllers, and what you should keep in mind as you're developing for them. So, what is Quest 3? Quest 3 is our next generation headset that will be available in 2 weeks with a number of substantial upgrades over Quest 2. So, what's changed? Well, there's 3 main areas to look at when it comes to the Quest 3. Headset improvements. By this, I mean things like the increased display resolution or the increases in CPU and GPU processing power. As for mixed reality, the dual-color cameras resulting in high-quality color pass-through and new features like occlusion, scene mesh, depth APIs, and color lookup tables. Touch Plus controllers. Here, the highlights are the ringless design, VCM haptics, and the 2-stage trigger. So let's get started digging into these details. One of the biggest upgrades for existing VR developers has to be in terms of compute. The all-new Qualcomm Snapdragon XR2 Gen 2 platform represents an increase of over 33% in CPU performance compared to the Quest 2's XR2 Gen 1 platform. In terms of cores, there's only 6 CPU cores available compared to the Quest 2's 8 cores. Hold on, isn't that a downgrade? Quite simply, no. On Quest 2, 5 of the 8 cores were reserved for the operating system to use. On Quest 3, there's only 3 cores reserved for the operating system, meaning that in both cases, there's 3 cores available for developers. However, this does mean that some of your performance analysis tooling may need to change. On Quest 2, the cores available to applications are CPU 4 through 6. On Quest 3, this changes to CPU 3 to 5. But that's just one side of the coin. On the flip side, with the GPU, things are even better. The upgrade from the Adreno 650 of Quest 2 to the Adreno 740 of Quest 3 represents a significant boost, more than 200% the GPU processing power. In fact, we're revising some of our prior guidance. On MetaQuest 2 and earlier devices, we've had to warn developers away from deferred rendering. The GPU power just wasn't there. However, while still not for all applications, our early tests on Quest 3 have shown that this now can be a path worth evaluating and considering. While we're on the topic of graphics, let's go into some details of the optical stack. Quest 3 contains a 2064 by 2208 display for each eye, a significant boost over the 1832 by 1920 of the Quest 2. Just like the Quest Pro, these displays are rotated at an angle, making it significantly harder to pick out individual pixels, especially when you're looking at both displays at the same time. The default eye buffer size also received a boost, going from 1440 by 1584 on Quest 2 to 1680 by 1760 on Quest 3. Why not closer to the native resolution of the panel? Considering the distortion that takes place to make the image display correctly to users, we found this to be the best balance of resolution and performance. If you've got a particularly demanding application, remember that our VRCs allow you to adjust this render scale to as low as 85% of these values, while if you have extra GPU available, raising this higher can make your app look even better. The new dynamic resolution functionality available in V56 and later versions of the SDK allow you to automatically scale up and down based on application performance. What about the field of view? Quest 2's horizontal field of view depends on which IAD setting you're using, but the middle setting is 96 degrees horizontal. On Quest 3, we've increased this to 110 degrees horizontal, almost a 15% increase, and this is available for all users, regardless of how you've adjusted the IAD or lens position. Along these lines, it's worth calling out the smooth IAD adjustment of Quest 3. While those of you with Quest Pros may already be used to it, Quest 3 represents a return to a continuous IAD adjustment wheel, rather than the 3 set positions that are present on Quest 2. Another related comfort setting is how the glasses spacer works on Quest 3. Like many of you probably do, I need to keep my glasses on while I'm developing and switching between the editor and headset. Unlike Quest 2, where the glasses spacer was this odd plastic piece you'd remove the facial interface to install if you needed it, the ability to add more space for glasses on Quest 3 is built into the facial interface. Simply press the buttons located on each side of the facial interface, and then move the outer portion of the facial interface in or out, choosing between 4 different settings based on the size of your glasses. Now, let's talk about the weight of the Quest 3. The Quest 2 weighed 503 grams on its own, or 512 grams if you added in the glasses spacer. In comparison, the Quest 3, with its built-in glasses spacer, is 515 grams. In other words, it's about the same weight. However, with the changes to the form factor bringing everything much closer to your face, it's significantly more comfortable to move around and turn your head with a Quest 3. Speaking of that form factor, how did we improve it so much from Quest 2? This is largely thanks to the pancake lenses, which you may be familiar with from the Quest Pro. As we no longer need to have as much distance between the lens and the screen, we can bring all those components behind the screen, like the processor and the battery, in closer to your face. Of course, the upgrade from Fresnel to pancake lenses comes with a significant improvement in image clarity as well, removing the God ray artifacts that were so common with the older lenses. Let's zoom out for a moment and talk about RAM, storage, and battery life. Quest 3 contains 8 gigabytes of RAM. That's a 33% improvement over Quest 2. We expect most developers will use that for more detailed, higher resolution textures. However, the choice is, of course, up to the application developer, and there's plenty of other ways you might choose to use that memory. As for storage, there are 2 options available: a $499 model with 128 gigabytes of storage, and a $649 model with 512 gigabytes of storage. As games get larger and more complex, like with higher resolution textures, they'll consume more space. The 512 gigabyte model allows you to have more games and applications installed on your headset at once, making it easy to switch between them without having to uninstall one in order to have enough room to install and play another. Regarding battery life, Quest 3 does require more power than Quest 2, but has a larger battery to deliver it. While gaming, our expected battery life remains about the same, at about 2.4 hours of gaming use or 2.9 hours of media use. However, when utilizing the new mixed reality features such as color pass-through and the depth API, battery life will be lower. The trade-off, though, leads to some amazing results. What sort of results? Well, I'll take a moment to talk about my favorite example, piano vision. I took piano lessons while growing up, and while I can read sheet music, Piano Vision's approach to teaching you to play the piano is really something else. While it has modes that just use hand tracking, connecting a MIDI keyboard is where it really shines. It's just an outstanding experience that I encourage you all to try. This sort of new use case, teaching piano lessons, is the sort of thing I'm really looking forward to seeing in the years to come. What sort of amazing MR applications will you come up with? I'm excited to find out. So, what new MR capabilities does Quest 3 bring to developers? Well, first off, Quest 3 contains dual 4-megapixel color cameras. This is a big upgrade compared to Quest Pro's single 1-megapixel color camera, eliminating the color bleed artifacts you'd see in Quest Pro's color pass-through. Of course, it's an even bigger upgrade over Quest 2's black and white 640 by 480 cameras. As a result, the quality of color pass-through is dramatically better. You really need to experience it yourself. The way I describe it is this. This is the first time I've really felt comfortable looking at and actively using a cell phone from within a headset. So, what's one of the first times you're likely to use color pass-through? It's when you do space setup to create a scene mesh. As you may have noticed, we've replaced the old manual room setup of the past with a new space setup process. Simply walk and look around the room, and Quest 3 will build up a representation of the environment around you. Applications can use this data, like they did with the old room setup data to, say, put items on a table. But when you set up your room with space setup, this also creates a scene mesh. The Mesh API enables developers to create fast collisions for physics and navigation experiences in MR. It's a full 3D mesh of the world around you that multiple applications can use to provide more precise interactions with the world than have ever been possible before. Next up, occlusion. Occlusion is another new feature that's available for developers and allows them to create a situation where the real world blocks or occludes a virtual object that the application is rendering. The easiest example to think of here is a character sitting down on a chair at a table. The table occludes their lower body from appearing, and all you see rendered virtually is their top half. Now, this one isn't quite done yet. While you could use the scene mesh for static occlusion, it's not recommended. You'll need the depth API to do dynamic occlusion, and it's only available as an experimental API in v57. Depth API gives you access to a real-time depth map, allowing you to occlude objects based on that dynamic information. Another new API I expect to see used in some creative ways is color lookup tables, or LUTs. Basically, this allows you to specify a mapping from one color to another for pass-through purposes. The simplest example? Imagine a scenario where you map all the green to red, and now all the plants around you in reality are red instead of green. Or take a look at the example pictured here. This room normally has white walls, and there's an orange pillow at the bottom. You can use color LUTs to turn the whole room orange, or you can be more selective and just use it to change white or gray areas to shades of green, while leaving the orange pillow alone, unchanged. Now, I'd like to set some expectations regarding compute and battery life when using the mixed reality functionality. You may have heard of this idea before. There ain't no such thing as a free lunch. Nowhere is this more true than when it comes to the mixed reality functionality on the Quest 3. The hardware features take up more battery power to run, and this eats up more of the thermal budget. As such, you should be aware of the constraints that exist for MR applications. An MR application that is making full use of the device may see battery life around an hour and a half instead of 2+ hours. In addition, CPU and GPU will be limited to lower frequencies and power levels to make sure the device can continue to function normally while these applications run without overheating or experiencing a brownout. Trust me, there's nothing I'd like more than to provide developers with the most CPU and GPU possible. We've got extensive monitoring in place to see if additional headroom exists. And if it does, it's something we'll consider in future operating system updates, similar to the recent changes we made to boost Quest 2. If this taste of MR has got you excited, don't worry. There's more coming up in the next session with Jay Golaguri and Britta Hummel. Now, let's talk about the all-new MetaQuest Touch Plus controllers that come with the Quest 3. The first thing you'll notice is that there's no rings, just like the Touch Pro controllers. This dramatically improves situations where your two hands are close together. No more ring collisions. However, the next thing you'll notice is that there's also no cameras. What sorcery is this? Well, we've put the LEDs of the controller ring into the faceplate, the black part of the controller, as well as one LED in the base of the controller, just beyond where your pinky and ring finger hold the controller. This, combined with some good use of the IMU data, along with some smart AI models, allows us to relatively accurately track the controllers without the tracking ring in a large majority of cases. One of the big differences you'll notice is when it comes to the tracking camera placement on Quest 3. Quest 2 had 4 cameras, a pair at the upper corners, and then a pair on the bottom towards the center on each side. Quest 3 also has 4 tracking cameras, but this time it's a pair at the lower corners and a pair in the center, roughly where your eyes are in a front view. This means the tracking volume between the two headsets is different. What do I mean by different? Well, larger for one thing. When comparing all the space tracked by both headsets, Quest 3 can view 91.79% of the space, while Quest 2 can only view 89.69% of the space. In other words, Quest 3 can see controllers in more of the space around you. Let's take a look at some views of the space around the user. From the top, this might look a bit concerning. Take a look at these images, comparing the theoretical tracking volumes for controllers. Quest 2 covers the area above you quite well, while Quest 3 leaves that area uncovered by any camera. However, it is worth noting that the area behind the user, where the cameras can't see, is actually smaller now than it was on Quest 2. The impact of this is actually more readily visible on a front view comparison. Now, these two images are the results of our tests to verify the difference between the areas where the controllers can be seen on Quest 2 and Quest 3. You'll notice that Quest 2 has a large area above the head where controller tracking is significantly better, and it also has a small area under the chin where tracking is better. However, the Quest 3 image shows bigger improvements. There's a large volume of space to each side of the user where controllers couldn't be seen before, but now can be seen. There's even a location that used to be a blind spot in close to the headset above the head that now gets some coverage. So, what about that area above the head? It's generally not an issue. For short periods of time, IMU data combined with our improved AI models are able to accurately position the controllers. And longer periods of time generally don't happen very often or very long. It's tiring for users to hold their controllers above their head for long periods of time. In short, the controller tracking on Quest 2 is better than Quest 3. It both covers a larger area than Quest 2, and it does a better job covering the areas you're most likely to have your controllers in. What if you have Touch Pro controllers? The Touch Pro controllers, announced at last year's Connect conference, also work with Quest 3 as well. You'll need to set up your Quest 3 headset using the included controllers, but once you've done that, you can unpair the Touch Plus controllers and pair Touch Pro controllers. So, for any applications that perform better with the unlimited tracking volume, or applications that want to make use of any of Touch Pro's other unique features, like the stylus, thumb pressure, or the thumb or trigger haptics, there's a solution available on Quest 3 in the form of Touch Pro. Speaking of haptics, well, the haptics on the Touch Plus controller are certainly improved, but not quite to the level of Touch Pro controllers. The Touch Plus controllers do not contain the trigger or thumb LRAs that the Touch Pro controllers do have, but they do each contain a single VCM haptics device in their base. This VCM allows for control over both the frequency and amplitude of the haptic effect. While it's quite similar to the VCM in the Touch Pro controllers, it isn't exactly the same. That doesn't mean you need to design your haptic effects twice, though. For the best developer experience, we recommend using Meta Haptic Studio. This application, released earlier this year, allows developers to create, audition, and integrate haptics just once, and then have them work appropriately across our full line of headsets. It's available for download now from our developer website and supports both Unity and Unreal. There's one more little secret hiding in these controllers. We've changed the index trigger on the Touch Plus controllers so that it is a two-stage trigger. What's that mean? Think of the current index trigger behavior as the first stage. Once you've fully pulled the trigger, you can now apply additional force to the trigger, and that will be measured via a second value, index trigger force. An afterburner for an extra burst of acceleration, an extra powerful boosted shot, or perhaps something requiring a bit of skill, where the user can get a little extra power, but pressing too hard will result in some sort of burnout. We're eager to see what designs developers come up with to make use of this functionality. So, how do I make use of all the new functionality? As always, it comes down to getting the latest version of our SDKs. The public v56 SDK contains some Quest 3 support, including Touch Plus controller models in Unity, and is a great place to start, while the v57 SDK, with even more, should be available within the next couple days. So, here's the point I want to leave you with. There's never been a better time to start developing for VR and MR. Quest 3's increased CPU and GPU power, along with more memory, allows you to create a more complex experience at a higher fidelity than ever before. greatly improved color pass-through, the Depth API, and color LUTs to power the most immersive mixed reality experiences. And, of course, the new ringless Touch Plus controller with improved haptics and the two-stage trigger. With that, you've got all the tools you need to develop for VR and MR, and Quest 3 is the device to develop for. I can't wait to see what you make.